In this video, we continue with inequalities, but we're now getting into what we call compound inequalities. These are inequalities in which we basically have two solutions in one. And there are two basic types of compound inequalities. One, in which today's lesson we'll talk about, which incorporates the word or in our inequalities, and the other, which we will talk about in a later lesson, which incorporates the word and in the inequality. So today we're just going, of the two, I think the inequalities with or are the easier ones to understand and to solve. So first of all, from a structure standpoint, they're going to essentially be two separate inequality statements joined by the word or. We'll solve each of those inequality statements as if it's its own inequality, but we'll put the solutions together with the word or by the time we're done. And what that basically means is that our solution will be represented by what we call the union, or a combination of the two respective graphs or the two respective solutions. So it really means that if I was testing a value as a solution, that I need to be true in either one of the inequalities or the other inequality. So here's an example of what would be an or compound inequality. X minus 3 is less than or equal to negative 2, and here's that word or that will always show up in an or statement. X plus 5 is greater than 14. So we're going to solve each of these as if it's its own separate inequality. So x minus 3 is less than or equal to negative 2 is going to have its own solution. X plus 5 is greater than 14 is going to have its own solution. And those two solutions are going to combine to make our final solution with the word or in between. So let's get started. So the individual sides of the or inequalities can take on different levels of complexity. We can see that each of these on its own is fairly straightforward. So in the x minus 3 is less than or equal to negative 2, we're simply going to add 3 to both sides. And we're going to get x is less than or equal to 1. On the other side, x plus 5 is greater than 14. That on its own also is a fairly straightforward inequality. So on that one, we're going to just subtract 5. And we're going to get, after we cancel out the 5s, x is greater than 9. Now this is not our complete solution. Our complete solution is the one side or the other. So that's our complete solution. And then from there, we're going to graph each of these on the same number line. So I set up my blank number line. For the x is less than or equal to 1, we're going to put 1 with a closed dot and a ray running to the left. Because if you notice this part of the solution on its own has a variable on the correct side, on the left side of the inequality symbol. And because my inequality symbol is pointing to the left, the ray for that part of our solution will also point to the left. We then move on to the other half of our solution. X is greater than 9, so we'll mark 9. You notice again for this individual piece, the x is on the proper side. It's on the left side of the inequality. Given the inequality symbol, we'll mark an open dot there. And since our inequality symbol is pointing to the right, then the ray for that will point to the right. So all of this together makes up our final answer. The solution to the original compound inequality of x minus 3 is less than or equal to negative 2, or x plus 5 is greater than 14, is a solution of x is less than or equal to 1, or, keyword, x is greater than 9 in the graph that goes with it. Okay, so we'll do one more example together, and then you'll have some practice to do. But as we move on, the other thing to emphasize is that all of the rules that would apply to when we were solving inequalities otherwise, in terms of flipping the inequality symbol when we multiply or divide by a negative, or turning our solutions around when they're backwards, are also going to hold true here, okay? So we just want to be aware of everything we've learned up until this point with other inequalities that were not compound inequalities. All of those rules still apply. So let's move on to the next one. We can see this is actually a two-step inequality. So we're going to start by subtracting 2 on both sides. And we will get negative 4x is less than 4. We'll continue solving by dividing by negative 4. Now this is going to cause our inequality symbol to flip around because I'm dividing by a negative, just as we were talking about. The rules that we have grown used to apply. So this is going to turn into x is no longer less than, is now greater than negative 1. So that takes care of the left side of our or statement. We'll move on to the right side. The right side is a fairly straightforward inequality on its own. We'll simply divide by 2. And we will get, I'm going to bring that down to be in line with the other. We will get x is less than or equal to negative 3. Now again, don't forget, we want to join the word or in there, okay? Now, if you take a look at this solution, you'll notice that the variables are on the correct sides. The x is on the left in the blue side, the x is greater than negative 1, and the x is on the correct side on the red part of our solution, x is less than or equal to negative 3. But what you should notice is that these values run in increasing order. And what I want us to do is to have these solutions run in decreasing order. So they run in decreasing order. Negative 1 is a bigger number than negative 3. We want them to run in increasing order. So what we want to make a note of is reorder the parts from least to greatest. So that means all of this is going to jump in front, and all of this is going to jump in back. So let's see what that looks like. We're just going to rewrite. So the smaller of our two values, x is less than or equal to negative 3, or followed by the larger value, x is greater than negative 1. That's going to be our final answer. And there's actually a really good reason for that. When we draw our number line and we set up our values, we're going to put negative 3 and we're going to put negative 1 in their respective places. And we know negative 1 is a bigger number, so it's closer to 0 than negative 3. I want this part on the left, when I graph it with an open dot into the left, to naturally run to the left. So I want the left side to point to the left, and I want the right side of my solution with an open dot to run to the right. So when we have everything in the right place, then the left side naturally points to the left as part of our graph. The right side points to the right as the other part of our graph. And what we get is what I refer to as oars of a boat. So think about this being one oar in a rowboat, another oar in a rowboat, and the middle basically being the rowboat. So the left side being the smaller value is the left oar. The right side being the bigger value of our solution is the bigger oar. So that's another thing we also want to be aware of, that when we have these compound inequalities, when there's the two separate pieces, we want to order them or reorder the parts from least to greatest. So that gives us our final solution. So that's it for today's lesson. We'll have you do some practice and we'll talk more in class when we meet again.